Let's start the AWS Solution Architect Associate C03 Certification Preparation course. Today is the fourth lecture, and in this lecture, we will learn more about the first service topic, Compute Container Serverless. This is the Compute Container Serverless service topic map. Let's look at it one by one in order. First, we will learn about the most commonly used services in AWS. This service is EC2. The full name of this sheet is Elastic Compute Cloud, and it is an IaaS service that provides servers. If we use a server at the IDC center, we will need a server rack network infrastructure and the OS of the server. AWS sets up an infrastructure settings and the hypervisor, which is software that virtualizes servers and allows them to be shared. AWS users can be seen as using a virtual machine, VM, on a hypervisor. You can think of it as using a VM. For the VM, the user can install a guest OS and configure scale out and availability settings. And you can use it by uploading an application on top. So how do you make EC2? We need to install a guest OS, but at this time, it already been installed. There is an image that configures the guest OS by OS. This is called the Amazon Machine Image, also known as AMI. At this time, the image is a template file containing the virtual machine's operating system, application, data, and settings. And you need to determine the instance type of this EC2. And the instance type of this sheet must be determined. By selecting the instance type, the user can select the components of the virtual machine according to the purpose of use and on which network this EC2 is connected, storage volume of EC2. There are types of storage as well as volumes, and you need to set the access control for EC2 in the security group. The VPC and security group parts are different in the networking and content delivery time, as well as the storage part, which will be discussed in detail in the storage service topic. Let's take a closer look at the Amazon Machine Image, AMI. As I said before, an image is a template type. Inside the template, there will be settings for the OS and software. So, when creating this EC2, the user will select an image of a specific AMI. The OS we want to create may vary. You can make it different for each type of Amazon Linux or for each setting. I told you about the instance type earlier, and the instance type is a type for EC2 computing. Each string that appears in the type has a meaning. In this case of the English spelling in front, it means it has an instance family. There are also different types of instance families. First of all, we mostly use them. There are T, M, and MAC for general purposes. It can vary depending on whether to optimize computing, optimize for memory, accelerate computing a little more, or optimize for storage location. You can figure out which instance this is by looking at the alphabet string in front of it. Secondly is the generation. You can see which generation it is by looking at the value behind the period. Let's take a closer look at EC2's pricing plan, which often appears in exams. I told you that EC2 is a service that rents an IaaS server. In the case of on-demand, it is strictly based on usage. When we use this instance, we use it when the situation keeps changing or when we do not know how long we will use it. Next is the reserved instance. In the case of reserved instances, it is for 1 to 3 years. You pay the cost first, and this cost can be discounted by about 72% compared to on-demand. This instance is usually suitable for instances that will be used for more than a year. There is also a pricing planning savings plan. The savings plan is also the same. You can receive a 70% discount, but you first have to pay for 1 to 3 years first. However, there is also a big difference between a reserved instance and a savings plan. In the case of a reserved instance, you must select an instance family and cite it in advance. However, in the case of a savings plan, you can select multiple instances. So, if you operate various services, we recommend going with the savings plan. Next is the spot instance. Because of this, it is a little cheaper. You can get discounts of up to 90%. If you are annoyed by cost efficiency, you can use spot instances. Usually, we use spot instances a lot in our development environments. Lastly, it is our dedicated. In some cases, it is used for services where compliance or security is important. And in this case, it is an EC2 instance type that is used in isolation so that it is not shared with other users or other instances. So, in this case, like the dedicated instance, an emergency occurs and the cost is $2 per hour additionally. Let's take a look at the function. If you use the autoscaling function, you can automatically add and remove servers according to the situation. Adding a server is called scaling out. Removing a server is called scaling in. For example, adding a server according to the CPU usage rate. Alternatively, you can add a CPU. If you set Amazon AMI information and conditions for server addition in the launch template, the server will be automatically added according to the conditions. These conditions include target utilization, such as CPU utilization, number of user connections, and can be used when an instance is not operating to prepare for failures at a certain time. This function is free, and users only have to pay for increased instance fee. The autoscaling function is available for services other than EC2. Next, let's learn about the AWS Batch service among computer services. With the AWS Batch computing service, you can utilize resources as efficiently as possible by dynamically transferring optimal computing resources when needed. When we usually do batch scheduling, we think a lot about cron jobs. You can think of the service that can be provided with this cronable AWS service as AWS deployment. When we do replacement scheduling, we also need to consider resources on the server, and AWS dynamically provisions those resources. So, in AWS Batch, we use this service to reduce management. In addition, for Spot instance, we use this instance in order to expect savings. Now for more information, take a look at the FAQs. Now in the following, compute AWS Outposts. Now what is AWS Outposts? Well, AWS Outposts delivers AWS infrastructure and services to on-premises or edge locations for a consistent hybrid experience. Based on the graphic, you can see that the cloud between AWS service and data center are interchanging. Within the data center, you can see how AWS Outposts are scaling out as AWS service is scaling in. You can see how those two things are interchanging. Now moving on, we want to talk about what is VMware Cloud on AWS. AWS, with extensive experience in supporting large-scale VMware customers, is the longest-standing cloud provider. AWS offers proven migration and modernization options to simplify the transition to the cloud. Purpose-built services, programs, and incentives are also available to migrate VMware workloads. Lastly, options include modernizing to containers and serverless or moving to managed services. We also want to talk about what is AWS Wavelength. In AWS Wavelength, it combines 5G networks, high bandwidth, and ultra-low latency with AWS compute and storage services for innovative applications. Now, these are available in partnership with Verizon, which in the United States, KDDI in Japan, SK Telecom, South Korea, Vodafone, UK and Germany, and Bell, located in Canada. It is also ideal for high-performance mobile applications requiring ultra-low latency, such as game streaming and AR or VR services. It is suitable for enterprise use cases like IoT, live media production, and industrial automation with low latency needs. Finally, it enables edge data processing for image and video recognition, inference, data aggregation, and responsive analytics near data sources. For more information, check out the FAQs in the reference URL. Now, let's talk about what is container. Compared to server virtualization, it is much lighter and much faster. Virtual machine, VM, contains OS, middleware, and application. Container image contains application. Now let's dive a little deeper into what this means. In container, for the user, it is comprised of application, as well as scalability and availability management. As for AWS, it is comprised of host OS, Docker. Within this, there is OS install, OS configuration, and container runtime. Below this, for host, there is server HW, as well as data center and network infrastructure. Next, what is Amazon ECS and EKS and ECR? If you haven't heard about these terms, please check the other lectures before this to know more about Amazon ECS, EKS, and ECR. Amazon ECS Elastic Container Service, a fully managed container orchestration service that simplifies running, stopping, and managing Docker containers on a cluster. Next, Amazon EKS, Elastic Kubernetes Service, a managed service that makes it easy to run Kubernetes on AWS without needing to install and operate your own Kubernetes control plane or nodes. Amazon ECR, Elastic Container Registry, a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy container images. Please check the reference URL for more information. Here is a more graphic representation for what is Amazon ECS, EKS, and ECR. You can see in each individual node there are two containers. And in that node, there is a server, EC2 and Fargate. From the nodes, they transfer to Contained Image Registry, which we also known as ECR, Amazon ECR. And that container transfers to container orchestration. Within container orchestration, there is Amazon Elastic Container Service, and there is Amazon EKS. These are managed by AWS and managed by Kubernetes, respectively. Now, what is serverless? Now, for the host, it is application development. So just focus on logic. But for AWS, there are three categories: server, host OS, hypervisor, and host. First, for the server, it is comprised of scalability and availability management, as well as OS configuration. As for host OS and hypervisor, it has OS install. Next, for host, server HW, data center, and network infrastructure. Let's move on to serverless AWS Lambda. What is AWS Lambda? It is a serverless compute service that runs your code without managing servers. It also triggers functions in response to events, making it really easy to build scalable applications. Now let's take a look at the graphic. Application is separated into two things, SNS and SQS. They both utilize AWS Lambda to be transferred to mail or infrastructure. What is AWS Fargate? Well, in AWS Fargate, it is a serverless compute engine that works with Amazon ECS and EKS, allowing teams to really focus on coding while AWS handles server management, resource allocation, and scaling. Fargate supports multiple CPU architectures and operating systems, offering cost, agility, and scalability benefits for many cloud applications, reducing the total cost of ownership, also known as TCO. You can see that the reference graphic has two nodes, which both contain two containers. In a node, it is also known as a server, either EC2 or Fargate. What is AWS AppSync? Well, it connects apps to data and events with secure, serverless, and performant GraphQL and PubSub APIs. GraphQL is a data language that lets client apps fetch, change, and subscribe to data from servers. Clients specify the data structure they need, allowing them to get only the necessary data in the required format. Now you can see from the user to the client and to the server, they are all interchanging with each other. Now, after the lecture, let's try some example problems. Let's look at this one. A company wants to reduce the cost of its existing 3-tier web architecture. The web, application, and database servers are running on Amazon EC2 instances for the development, test, and production environments. The EC2 instances average 30% CPU utilization during peak hours and 10% utilization during non-peak hours. The production EC2 instances run 24 hours a day. The development and test EC2 instances run for at least 8 hours each day. Now, the company plans to implement automation to stop the development and test EC2 instances when they are not in use. Now the question is, Which EC2 instance purchasing solution will meet the company's requirements most cost effectively? That's the question, right? Which EC2 instance purchasing solution will meet the company's requirements most cost effectively? All right, so let's look at the answers provided in this question. So first and foremost, when we think about production, we think about which connection and relation it has to instances, right? Now this instance must have 24 hours, so it shouldn't be turned off. Next, we should also know that it can be constantly used, right, without stopping. So if we look at B, it has reserved instances, right? But reserved instances have 72% discount. And after that, test. Now test and development, right? What's important here is spot, right? Spot instances. So we think we can use spot instances, but at the same time, if we're not going to be using spot instance as much, then automation to stop is not going to be required or necessary, right? And we want to turn it off at one point or at some point. Now let's think about on demand, right? On demand is going to be more in relation than spot instances, right? Basically, we want to be using this based on how much we're actually going to be using it, right? So when we think about production again, we think of reserved instances, right? Use on-demand instances for the development and test EC2 instances. Therefore, B is the answer. Let's look at the next problem. A company is designing an application, right? The application uses an AWS Lambda function. This Lambda function uses the Amazon API gateway and to store the information in an Amazon Aurora PostgreSQL database. Right, so during the proof of concept stage, the company has to increase the Lambda quotas significantly to handle the high volumes of data that the company needs to load into the database. A solution architect must recommend a new design to improve scalability and minimize the configuration effort. So the question is, which solution will meet these requirements? Essentially, we have to use a Lambda function, right? And so we have to be looking at serverless solutions. So like mentioned in the question, it talks about it has a Lambda, and that transfers to Aurora database. Now the important part here is the configuration effort needs to be down, or it shouldn't be as impactful. So in the serverless, inside of that, it needs to have a low configuration effort. So let's look at A. Refactor the Lambda function code to Apache Tomcat code that runs on Amazon EC2 instances. For B, change the platform from Aurora to Amazon DynamoDB. C says set up the Lambda functions. D says set up the Lambda function. Right, so we'll be looking at keywords in each answer. D also talks about Amazon Simple Queue Service. Now in this case, we want to be reducing configuration effort, right, for this specific problem. Therefore, EC2 instances are pretty heavy, so that's not going to be required. Right? And in the problem, it specifically says that it's going to be using Amazon Aurora PostgreSQL database. Right? So Amazon DynamoDB is not going to be required. So the remaining answers are what? C and D. But when we'll be using Lambda functions, now, when we think about Lambda quota, you have to be using two services at once, right? Therefore, D is the answer. Let's finally try an example problem. A company wants to use Amazon Elastic Container Service, Amazon ECS, clusters, and Amazon RDS DB instances to build and run a payment processing application. Payment processing. The company will run the application in its on-premises data center for compliance purposes. A solutions architect wants to use AWS Outposts as part of the solution. AWS Outposts are important. The solutions architect is working with the company's operational team to build the application. We're building an application, right? Which activities are the responsibility of the company's operational team? Which activities are the responsibility of the company's operational team? The responsibility of the company's operational team. Remember, AWS Outpost and on-premise are in relation with each other. All right, so let's look at A. Providing resilient power and network connectivity to the Outpost racks. We're providing power and network connectivity, right? The responsibility of a company's operational team. So A is an answer. B. Managing the virtualization, hypervisor, storage systems, and the AWS services that run on Outposts. So Outposts to AWS. But we're looking for the responsibility of the company's operational team, right? So managing the virtualization of hypervisor, storage systems, and the AWS services that run on Outposts is not the job or responsibility of an operational team. For C, physical security and access controls of the data center environment. Physical security and access controls, responsibility of the operational team. So let's look at D, availability of the Outpost infrastructure, including the power supplies, servers, and networking equipment within the Outpost racks. Therefore, D is not an option. E, physical maintenance of Outpost components. We already know it's going to be the responsibility of the company's operational team, so E is an answer. F, providing extra capacity for Amazon ECS clusters to mitigate server failures and maintenance events. Again, with maintenance, it is in relation with AWS. And when we think about customer, think about physical customer, right? So the answers here will be A, C, and E. So now let's look at the next problem. A solutions architect is implementing a complex Java application with a MySQL database. So Java application and MySQL database. The Java application must be deployed on Apache Tomcat and must be highly available. What should the solutions architect do to meet these requirements? So let's look at A. Deploy the application in AWS Lambda. Configure an Amazon API Gateway API to connect with the Lambda functions. And for B, deploy the application by using AWS Elastic Beanstalk. C, migrate the database to Amazon Elastic Cache. For D, launch an Amazon EC2 instance. Install a MySQL server on the EC2 instance. Configure the application on the server. Create an AMI. Use the AMI to create a launch template with an auto-scaling group. Now for AWS Lambda, according to answer A, it is in connection with OS, which is not what we want. As for C, Amazon Elastic Cache is going to be in relation to DB, which is not what we want. But we look at AWS Elastic Beanstalk and answer B. It is a complex Java application. That's what we're trying to implement, right? So the best answer here is B. But let's look at D. Launch an Amazon EC2, which is in relation to IaaS, but we don't want that either. We want our solutions architect to implement an application that is in relation to PaaS, right? So the best answer here will be B, because with PaaS, it is in relation to AWS Beanstalk. Thank you so much for tuning in to this lecture. I hope you learned a lot, and I hope the example problems helped a lot. If you have any more questions, please refer to FAQs or the previous lectures. In the next class, we will learn more about storage. See you then.